Hello, welcome to video number 32. Today's video is called Diameters and Tangents, and we should throw a party. This is the last video for our angles unit. All right, this is going to be quick. We want to talk about two types of problems. The first type of problem involve problems that have a diameter drawn. Like in the first problem, number 1 here, segment AB is a diameter. And that means something. That means angle C down here is a right angle. So already I know that C is 90 degrees, or Z rather, angle C, which is marked Z in the figure. So this is 90 degrees. The reason why is because that's an inscribed angle. The point's on the circle, and it cuts off this semicircle. Angle C belongs to that arc, and so it's half of 180 or 90. Okay, now that's an important feature with diameters. Wherever point C was located in the figure, as long as it's on the circle and it cuts off a diameter, C is going to be 90 degrees. So as we slide it around the circle, it would stay 90 in this case. Okay, X is easy to find because X is half of 50. So X is an inscribed angle also, so it's 25 degrees. And since this is a triangle, they add up to 180. I believe that leaves this one as 65. Okay, so we found X, Y, and Z. 25, 65, and 90. Okay, and the key is realizing that this is a right triangle. And problem B, this is more like a question we had asked on a quiz. In the figure below, the measure of angle P is 4 times the measure of angle Q. Find the measure of angle P. All right, so the key is this is a right angle. So I'm going to draw in a little box there. And the reason why is it cuts off a diameter. And again, this is 180 degrees here, being a semicircle. So angle R this time is 90 degrees. Okay, we have to set this up. It says the measure of angle P is 4 times the measure of angle Q. So angle P is given in terms of angle Q. So if I let angle Q be X, then P would be 4 times that, which is 4X. So P is given in terms of Q. So let Q be the variable. Okay, now once we have the setup, this problem is a piece of cake. It's all in setting it up. So the angles of triangle add to 180. So we have 4X plus X equals to 180 degrees. So 5X equals 180. And X is going to equal 36. Now, that's actually not the answer to the question. That's the measure of angle Q, since we let angle Q be X. But it says find the measure of angle P. So the measure of angle P is going to be 4 times 36, which would be 120 and 24, I believe is 144. So if you have this question on the quiz, be careful to give the angle they ask for. So we could get X equal 36, feel all happy about it, be ready to party, celebrate, but that isn't what they asked for. We got to answer the question. Find the measure of angle P, which was 4X. Okay, no problem. So watch out for that. Again, if they give angle P in terms of angle Q, let angle Q be the variable, write an expression for angle P. That was half of it. The other half involves problems with tangents. So in this first diagram, this segment here is drawn tangent to the circle. A tangent touches the circle in only one place. And the fact you gotta remember is that if we draw a radius to the point where the tangent touches the circle, it makes a right angle. So this right here is a right angle. Down here, here's another tangent line that just touches the circle in one place, and it will kind of continue on past the circle. And we have a radius drawn to it, so that's 90 degrees also. Suddenly, we got 3 angles of a quadrilateral, and we can zoom in on X and find it. So we're going to take 360, because that's the total for angles of a quadrilateral, subtract the two 90s, and then subtract the 56 degrees, and we get X equals 124. Okay, so once we realize that these two angles are 90, that became really easy. Over here, it's a little bit more complicated. So angle B is a 90-degree angle. This entire angle here is 90 degrees because, again, we have a radius drawn to a tangent segment. That's 90. If that's 90 and this is 32, we can get this angle C. So angle C is whatever's left. So 180 minus 90 is 90, minus 32 is 58. This must be 58. Okay, now we have to use the fact that this is an isosceles triangle. It's actually isosceles because CB is a radius and CD is a radius of the same circle, so they have to be congruent. And they're marked congruent for us. So if we do 180 minus 58, that's 122. And if we divide that by 2, we get 66. So this part of angle B is 66. And X is 66 also. So we found it. X is 66 degrees. So the combination of two things, using the right triangle, and then this smaller triangle is isosceles, and using that. Okay, so we had this question in class. It's on the quiz too. Which is longer, segment BC or segment BD? Well, remember, bigger angles go with bigger sides. So the side BD is opposite of 58, which is smaller than what's opposite BC. So 66 degrees is opposite BC. So the bigger sides, gotta go with the bigger angle. BC is opposite 66, BC is the bigger side. Okay, so bigger sides go with bigger angles. When I say that, the side I'm talking about is the side that's opposite the angle. All right, here we go. Guess what it's time for? It's journal time. Okay, so here's one problem of each. So in number 1, the measure of angle A is twice the measure of angle B. Find the measure of angle A. Remember, this is a diameter, so C's got to be 90 degrees because this is a semicircle over here. Okay, in this figure, kind of like the last one we did, CB is tangent to the circle, and it makes a right angle with AB. Got to find X. Okay, good luck.